Feynman once said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." This very famous quote is one of the best descriptors of our understanding of this field, and mainly because of how abstract and mathematical and not intuitive it is. However, quantum mechanics in today's day and age are pretty much understood. We can predict a lot of behaviors of particles in a lot of scenarios based on the theories of this discipline. Hell, we can even use this field of physics to build technology like quantum computers and other nanotechnology. So how exactly does this quote still apply? On episode 19 of the first season of Young Sheldon, we meet one of the first mentors of our protagonist, Dr. Sturgis. This Dr. Sturgis has a PhD in quantum chromodynamics. And when I first heard that term, that being while watching the series, I was wondering, what does it research? What is it focused on? I've never heard of it before. In quantum mechanics also exists a concept of what I can say a relative field of study, being QED or quantum electrodynamics. But what are they? What are QED and QCD? Obviously, QED describes the electrical forces working on the quantum level, showing us how atoms form of positively charged protons and negatively charged electrons. Or more accurately, I can say that of positively charged cores and negatively charged electrons. Also, QED explains a lot of chemical phenomena, explaining bonds between atoms and building heavier components. A matter that a QED physicist might tackle is, for example, why do hydrogen atoms always seem to appear in pairs? Why do we always have H2 and never just H by itself? One last important thing to point out is that QED can be described as the theory of interactions between electrical charges on the quantum scale. This is important. By that, you can deduce that the name of quantum chromodynamics, or QCD, will also tell you what it will study. Let's analyze this quantum, because chromodynamics, meaning that we try to explain some force using some type of colors. But what are colors in quantum mechanics? Turns out that to describe quarks, we have to use a concept called color. And this is not exactly the color you imagine. This word is simply used to suggest that the color charge can come in 3 possible values with corresponding antivariants. Color can obviously be explained using the RGB colors of red, blue and green, with what I like to do and a lot of other people explaining it like to do, use the color palette of subtractive colors, being cyan, magenta and yellow, to describe the anti-colors. Of course, this explanation is purely for our intuition, as in reality neither quarks nor gluons, to which I will get to in a minute, have actual colors like we imagine them, although that would be interesting. Like I said, quarks and gluons. But why? Well, it turns out that in order for the color charge to be conserved in atom cores, gluons also have to have a color charge. Now it all comes together. Gluons have a color charge, and if somebody isn't aware, gluons are the carriers of the strong nuclear force. It's holding together atom cores against the repelling electrical forces between protons. QCD is the study of the strong nuclear forces. Quantum chromodynamics is the field trying to understand what's happening in the atom core by analyzing the strong force field of said core. Both QED and QCD are parts of the main boss of quantum mechanics, being quantum field theory, or QFT. Quantum chromodynamics fascinated me, and I will try to understand more about it and explain it all to you. Thank you very much for watching.